Section 7.4 is about adding and subtracting radical expressions. When I'm adding and subtracting radical expressions, we can only add expressions that are like radicals. So if two or more square roots or cube roots or fourth roots have the same radicands, that means what's under the radical, then they are called like radicals, right? We treat these really similarly to like terms in an equation, and we combine them. So for example, if I had 7x plus 6x, that would give me 13x. Well, here I have 7 square root of 11 plus 6 square root of 11, which gives me 13 square root of 11, because 7 plus 6 is 13. What we do need to remember, though, about radicals is we have to simplify them before we can add them. So if I have 2 square root of 18 minus 5 square root of 2, I need to remember that 18 factors into 3 squared times 2. So that becomes the square root of 3 squared times 2. So my 3 is going to move to the outside. I get 2 times 3 square root of 2 minus 5 square root of 2. So 6 square root of 2 minus 5 square root of 2 equals the square root of 2. So why don't we go ahead and practice some examples. Okay, so if I have the square root of 5x minus 7 square root of 5x, first I make sure that I can't simplify what's under my radical, and I can't. So if I have square root of 5x, that's like there's imaginary 1 coefficient in front of that, minus 7 square root of 5x, that gives me a negative 6 square root of 5x. Now let's try this again. I have 7 square root of 3 plus 12. Well, 12 factors into a 2 and a 6 and a 2 and a 3. So I have 2 squared times 3. And I'm collecting squares because I'm taking the square root. If I was taking the cube root, I'd want to collect cubes. So I have 7 square root of 3 plus the square root of 2 squared times 3. That gives me 7 square root of 3 plus 2 square root of 3. So because that 2 moves to the outside, square roots undo squares. So I have 9 square root of 3. Let's do this again. I have 3 square root of 24 plus the square root of 54. Well, 24 is going to factor into a 2 times a 12, which we already know is a 2 and 2 and a 3. So I'm going to have 2 2's. So I want to write 24 as 2 squared times 2 times 3. Next, I got to take the square root of 54. 54 factors into a 2 and a 27, which factors into a 9 and a 3, which factors into a 3 and a 3. So I'm going to write 54 as 3 squared times 3 times 2. This 2 is going to come to the outside, so I have 3 times 2 times the square root of 2 and 3, which is 6, plus this 3 comes to the outside, so I've got 3 square root of 6. So now I have 6 square root of 6 plus 3 square root of 6, which equals 9 square root of 6. Now, friendly reminder, I am showing you every single step. If you don't need to make a factor tree, if you remember what something factors to, as long as you're factoring these radicals properly, go for it. You don't have to write it out every single teensy step. I'm just doing that to make sure nobody gets lost. So if I have 2 square root of 20 minus 45x, that's going to be 2 times 20, which factors into a 4 and a 5. 4 is 2 squared, so 2 squared, 5 times x, minus the square root of 45. Well, that's 9 and 5. 9 is 2 3's. 3 squared times 5x. That gives me 2 coming to the outside, so I'm going to have 4. 2 times 2 is 4. Square root of 5x minus 3 square root of 5x. That just leaves me with 5x. The square root of 5x to be exact. Looking at example 5, I have 2 square root of 3 minus 4 square root of 5. These are not combined radicals, so I cannot simplify further. because they need to have the same radical in order to be added. Let's look at a couple harder examples. So for example 1, I'm taking the cube root of x squared y plus the cube root of negative 8x to the 5th y. So before, where I was collecting squares, now I'm collecting cubes. I have 2 cube root x squared y plus the cube root of negative 8, which is negative 2 cubed, and then I can break apart this x to the 5th, x cubed times x squared y. So I have 2 cube root of x squared y plus negative 2x square root of x squared, cube root of x squared y. Well, I can't really combine like terms here because I've got a 2 and a negative 2x, but I could factor out the greatest common factor, which is the square root of xy. So I've got 2 minus 2x times the cube root of x squared y. Now let's go ahead and simplify number 2. I have 5 square root of 4x cubed. Well, that's 5, 2 squared x squared x. This is a square root, so I'm collecting squares, plus 3 cube root, so I'm taking cubes, 4 cubed x. So now I have this 2 and this x come out, so I have 10x square root of x plus this 4 comes out and this 3 comes out, 12x cube root of x. Okay, so I can't add these radicals, but I could pull out the greatest common factor, which is a 2x. So I'm left with 2x 5 square root of x plus 6 cube root of x. For our last example, we need to remember that I am taking the square root of a radical, which means I take the square root of the numerator and the square root of the denominator. So I have 2 square root of 75 over the square root of 16 plus 4 square root of 8 over the square root of 32. 75 is 3 times 25, so I have 2 square root of 5 squared times 3 over 4 plus 4 square root of 2 squared times 2, because 8 is 2 squared times 2 over 32. Well, friendly reminder that 32 is 2 to the 5th, so I have the square root of 2 to the squared times 2 squared times 2. That gives me 5's 2's. So now I have 2 times 5 square root of 3 over 4 plus 4 times 2, which is 8 square root of 2 over 4 square root of 2. Well, my square root of 2's cancel, so does my 4, so I have a 2. Then this is 2 times 5, but I have 4 in the denominator, so they both have a factor of 2 that can cancel. So I have 5 square root of 3 over 2 plus 2 is my final answer, and I can't simplify that any further.